Hi students, welcome to STP. So today's topic is surface tension. We are going to discuss what is the surface tension, what is the cause behind it, and how we can measure it. And we will proceed also in the coming sessions about the applications of the surface tension. So let's first learn what is the surface tension. So it is a property of the fluid surface due to which it behaves like a elastic membrane or acquires minimum surface area. Like for example, if you take a rubber surface or a elastic surface and in which you put any object, okay, so like if you put it, so this surface will get down, but still it will try to keep this object on the top of the surface. Similarly, the surface tension, similar properties the surface tension, like if any mosquito sits or if any needle you keep it on the water surface or on any liquid surface, so this liquid surface will act like a elastic membrane and it will go down a bit, but in this object will not completely sink in this fluid. Okay, so this the property due to which this kind of behavior is coming is called as surface tension. So now what is the cause behind it? The cause is the cohesive forces or cohesion. Now what is the cohesive force? So cohesive force is the force acting between two similar type of the particles. Like here, if a particle of fluid, like let's say water is there, so H2O particle is over here and the another H2O molecule is over here. So the force of attraction acting between them is known as cohesive force. So due to this surface tension is coming. Now how it is coming, we are going to just learn it, but this is a graph between the cohesive force and the distance between the particles. So if there is the distance 10 to the power minus 9 meter, if particles are beyond this distance, then they will not be able to feel so much cohesive force. So that's why the cohesion will not occur in between them. So this distance is known as radius of influence. So now if you take any fluid, like here I have taken the example, if you take any fluid in a container and fill it, so if you take these three particles A, B, C, so C particle will be in equilibrium if you see the cohesive forces, because all around it there are the particles and they will attract it. So that's why the total force will be 0, and so that's why it is free to move. But if you take particle B or especially the particle A, so particle A is feeling the cohesive force due to these downward particles. There is no any particle above this point, so that's why there is a total downward force on this particle A. Due to this, particle A is feeling a downward force, and this is the reason of surface tension. Due to this fluid surface is trying to acquire the minimum surface area, and if you want to pull this particle, you need to apply a force for pulling it. Okay, so now this is the reason. Now how do we measure the surface tension or the any property related to surface tension? So for measuring a surface tension, we do this kind of experiment in which this is a wire structure. This blue structure is a wire structure, and this is a massless rod that we are keeping in contact with the fluid film. So when you practically measure it, you pull it with a force. So this force will be that we are pulling will be equal to force due to surface tension. So now this force will be proportional to contact length. It means when you start pulling it, and if you bring over this point, this rod, if you bring at this point, then you are going to feel extra force, a bit extra force. Okay, so from there we can understand that the force due to surface tension is proportional to the contact length. Now proportionality sign can be we can remove it by using a constant, proportional constant T. Now T we can define as the constant, and this is known as coefficient of surface tension. So coefficient of surface tension will be equal to force due to surface tension divided by contact length. This is how we define the coefficient of surface tension and property related to surface tension. So in this video we have discussed about the surface tension, cause behind the surface tension, and how we can measure it. What is the formula for the force due to surface tension? Force due to surface tension is coefficient of surface tension multiplied by contact length. Now this is a practical data that will be given to us Okay, and that depends on the question, which type of question it is. So like if they are asking the force due to surface tension, so this data will be given to us. Like generally for the water, the coefficient of surface tension is 70 multiplied by 10 to the power minus 3 Newton per meter. Now this is a property, this coefficient of surface tension is the property of the fluid. It depends on the fluid, and it will not change if fluid's property are not being changed. But still, if you increase the temperature of the fluid, then coefficient of surface tension will decrease. So just a few more things I can say, that coefficient of the surface tension is inversely proportional to the temperature. This is a temperature, this is a coefficient of surface tension. One more thing, if you generally add impurity to any substance or fluid, then the coefficient of surface tension will decrease. So if you add some impurity, like if you take a pure water and another impure water, so in case of impure water, the surface tension will be lesser compared to the pure water. And we will also see the application of this when we will go to the capillary rise. So I think you have understood this. If you have find any doubt, you can just post it. Thank you very much. Let's end over here.